So systematic error is error that causes your data to either be too high or too low. So when we talked about uncertainty, right, or random error, we said it can cause our results to be both too high and too low. And so the way that we reduce random error was to do multiple trials and average. Systematic error is where anytime it is present, it causes your results to be either too high consistently or too low consistently. And so that, when we have systematic error, it's going to lead to what we call poor accuracy, meaning our measured values are not going to be close to the true or accepted value. So accuracy is how close your measured values are to the true value or the accepted value. And so our one-word description of accuracy is correctness, right? And so if we're using the analogy of hitting a target, when we talk about accuracy, it's how close we get to the target that we're trying to hit. And so to quantify accuracy, we use percent error. So percent error is a way to quantify the accuracy of a measured value. So to find percent error, we need our measured value, what we found in the lab, and the accepted value. And then we've got a formula. So we find the difference between measured and accepted and divide by accepted. And if you look at the board, what do these two lines around the formula mean? Absolute value, which means we're going to make our error what? Positive, right? And then multiply by 100 to make it a percent. So I'm going to give you a second to write down the formula and description of percent error, and then we will talk about it. So we're going to find the difference between our measured and accepted value, and then we're going to divide by the accepted value and make that quantity positive, and then multiply by 100 to make it a percent. So the higher the percent error, the less accurate your measurements are, right? The farther your measured values are from the accepted or true value. So let's look at an example together. So the first example says the density of water at 4 degrees Celsius is known to be 1 gram per milliliter. 1 gram per milliliter. Lucille experimentally found the density of water to be 1.08 grams per milliliter. What is her percent error? So let's find percent error. So what is the accepted value for the density of water in this problem? Good. 1 gram per milliliter is the accepted value. And then what about the measured value?
1.08 grams per milliliter.
Good. 1.08 grams per milliliter. So we're going to find measured minus accepted. So 1.08 minus 1.00 divided by, do we divide by accepted or measured? Accepted, which is 1.00. Do we need to keep up with the 0.00? Yes, why? Those zeros are significant. So find the difference, 1.08 minus 1.00, and then divide that by 1.00, the accepted value, and multiply by 100 to give us a percent. So how many significant figures should our answer have? I would take 2 or 3. When you subtract, you'll get, actually I take 1, 2, or 3. When you subtract 1.08 minus 1.00, you'll get 0.08, which has 1 significant figure. So I would take, for this, I would take anywhere from 1 to 3 significant figures is correct. Let's report it with 3. So if we multiply our error by 100, what do we get?
8%.
Good. Very good. Okay. Let's look at another one. So this one has several parts. So we have a set of data. It says the following measurements were made to determine the density of a material whose value, according to the Handbook of Chemistry and Physics, was 1.24 grams per milliliter. That's the accepted. Good. So now let's look through what we've been asked to do. So determine the percent error. So to determine the percent error, we're going to need the average. So let's look at what part B says. B says determine the uncertainty of the average for the experiment. If I was working this problem, I would actually do B first. So let's look at B. So B, we're going to find the average with the associated uncertainty. So to find the average, we are going to add the 5 trials together. And then divide by 5. Why divide by 5? There are 5 trials. So I got 1.22. Good. Now let's find the uncertainty. So what is the biggest value? 1.25. And the smallest? Good. And then divide that by 2. And what do we get for the uncertainty? Good. 0.03. And then the unit? Grams per milliliter. So, does my uncertainty have one non-zero digit? Yes. Is that one non-zero digit in the same place as the last significant digit of my measured value? Yes. Now, I'm going to go back and use the average value for finding percent error. And I'm going to use that 1.22 as the what value measured. So when I find percent error, I'm going to do measured, which is 1.22, minus accepted, 1.24. That's going to give me a negative number, but I'm going to make it positive. Then divide by accepted, which is 1.24, and multiply by 100. So again, for this one, I would take 1 significant figure, 2 significant figures, or 3. What'd you guys get for percent error?
1.6.
Okay. Good. And that is percent error.